Hello physical science students. Today we're going to do a quick tutorial on how to write in scientific notation. Now remember, our scientific notation is our number times 10 to the whatever place. That times 10 is our scientific notation. Do not ask me why. I'm not sure why it's written that way. I do know, however, if you put it into a calculator as this, it will give you the correct answer in the end. Maybe something to ask Mr. Flater about. You will get to scientific notation in math, but it's a bit later in the year. So let's get started. We're going to look at 4 problems today, mostly because I don't want to waste your time too much, and these 4 problems are the 4 different types of problems you will see and have to perform scientific notation with. Let's take a look at number 2 on the green sheet first. Number 2 is a really big number, and we want to shorten it. So, friend Brady told us yesterday in the book, it states that when we do scientific notation, it has to be a number between 1 and 10. That means I have to move my invisible decimal over until I get to a number that is between 1 and 10. So I'm going to move it over 1, 2, 3, 4, 5. That's all my zeros, but I'm still at 54. So I need to move over one more, 6. That means my new number is 5.4, because that is now where my decimal is. Now I'm going to add my scientific notation, my times 10, and I moved it over 6 times, so that means my number would be to the 6th. Since I'm moving in this direction, it is a positive 6. One way I like to think about it is whenever I have a really small number, I'm going to have a negative. Whenever I have a really big number, I'm going to have a positive. Okay, now let's try one in the opposite direction. So let's take a look at number 4 on our green sheet. My circle's a bit big. Let's erase some of that. All right. So I have 0.009. I need to move my decimal to make it first a number between, again, 1 and 10. So, decimals here, I'm going to move it over 1, 2, 3. That'll give me 9, because I moved my decimal behind the 9. Now I have to add my times 10. I moved it over 1, 2, 3 times, but I moved it in the opposite direction. So it would be a negative 3. I started with a really small number. I changed it to a bigger number. It is going to be negative. Flipping to the back side here, let's take a look at number 18. Now this is one that's already written in scientific notation that I would like to change back to its original number. We have 2 times 10 to the negative 1. We know that we have a 2, and we know it's a negative. So that means my number must have been a small number. Decimal points over here. I have negative 1. That means 0.2 is my answer. Let's try to find one a little bit harder. Let's move down to number 24. All right, we have 8.3, and it looks like we're moving it to the 7. So we're going to have a really big number. 1, 2, 3, 4, 5, 6, 7. fill in all my zeros here. So it looks like my number is going to be a 3 with 6 zeros behind it. We moved it 7 places, yet there are only 6 zeros because my decimal is in between the 8 and the 3. Moving it over 1 place then leaves us with 6 more places to put zeros. I think that's where some of us were getting confused yesterday. So here's our final answer.